Wait,
Okay,
so,
why is the quiz, the third quiz, and then the test?
no, we've already had the third quiz.
We've had three
We've had
quizzes.
three quizzes. The test
The
is on
test is
Monday.
just Monday.
The test is Monday.
Wow, why'd you do that?
Hold on, wait, there might be.
I've been the one, I've been to school 5 times in the past since like Christmas.
Oh, I know. Yeah. Okay,
I've
yeah,
been missing 2
this
days.
is day 4 out of the last 2 weeks. Anyway, so assuming we're not gonna have a snow day on Monday,
Right now?
Wait, is there snow predicted on
no.
Monday?
No, it's supposed to be like 55 degrees.
Yeah.
Okay,
Never
so
say never.
that was,
I'm taking one of those outlets. They're mine.
Never give up.
My calculator is 10. Where's an outlet?
okay. Anyway, back to our
I didn't think you were done with your conversation.
So, none of that redox stuff that we started Monday will be on this test. So here's how today is gonna play out. We're gonna go over big ideas, okay? There's gonna be kind of 2 distinct parts of the test. There's gonna kind of be the acid-base part and then the KSP, QSP part, okay? And so then I'm also gonna give you like a blank review, and then I'm gonna give you the answer key to that review. So pretty much if you can do that review, you at least have a fighting chance of doing okay on the test. I'm not saying 100%, but I'm saying you got it. So you're saying there's a chance.
That's all.
We might pass.
That's all you can ask. So let's kind of go back to the beginning. So let's just start with this idea. A pen that won't write.
Powder across the face.
Why would a pen? Oh man, I guess.
Is that on the video?
Yes, we're rolling right now.
We're rolling.
In the side, you're just gonna hear Charles. Lines on.
Lines on the table. Use the big line. Use it as his phone.
Yes,
You
bro.
can
You definitely said it.
That was not helpful
And
at
then
all.
use the ID. So like,
Share next time.
Locking the free.
That's how you get on.
we could all use something.
Put some lines.
That's how you know you're cooked, when you have to get a full foot line.
That's how you know you're addicted. Because you can only fill out for a minute.
Okay, so let's just start with this. I'm gonna give you 100 milliliters of a 0.2 molar solution of formic acid. Ka is 1.8 times 10 to the negative 4. So let's start at the beginning. Fundamentally, what is the difference between a strong acid and a weak acid? And explain and use the word clumpy.
Weak acid, stay
Weak, clumpy. Strong, no clumpy.
I can live with that,
That,
okay?
I'm using that on the, I'm using that on the test.
So I can translate clumpy. So here's the story. So if you look at formic acid, HCOOH. Now technically, remember, we put this in water. A lot of times we don't write the water, but it's there, okay? So fundamentally, if this thing is gonna ionize, this water, it's gonna boil down to a tug of war. What has the stronger pull for that proton? Does the COOH anion have the stronger pull, or does the water? Now, remember, the water is a very polar molecule. It has a whole bunch of excess electrons around the oxygen end and a deficiency of electrons around the hydrogen end. So one end is positive and one end is negative. So this lone proton out here on the end has a decision to make. Do I stay with the COOH, okay, or do I jump ship and go with the water? It's a tug of war. This proton has to make a decision. Where am I going to go? In the words of Cohen, am I going to stay clumpy, or am I going to ionize? Okay? Now, here's the bigger idea. by virtue of the fact that you have a Ka, now remember, what's the only time you use an uppercase K?
Equilibrium.
If you're in equilibrium. So your Ka calculation, and it's always products over reactants. So it's always going to be in this situation, based upon this reaction, of potentially forming a hydronium ion and the anion. So it's your hydronium ion concentration divided by your anion concentration divided by the initial concentration of your acid. Cool. Now, let's jump back and let's assume that this was a strong acid. If this was a strong acid, why are there no Ka values for strong acids based upon a mathematical explanation? Charles.
What?
That's the most elegant explanation I've ever heard.
Would you accept? Will you
Can
accept?
you go beyond?
Because strong acids dissociate completely, there's the concentration of the acid will be the same as the concentration of the hydronium ion.
Yes, that's true, but that is the mathematical reason. What you said was true, okay? What you said was absolutely true. But that isn't why the K doesn't work. Christmas.
It dissociates completely, so there's no acid in the denominator.
Beautiful.
Divide by
That's
zero.
what I want to hear, okay? So if you mathematically try and calculate Ka, because this is at equilibrium, if this had been a strong acid, which it wasn't, but if this had been a strong acid, this value at equilibrium would basically be zero. So you're dividing by zero, which makes it undefined, or you're dividing by a really, 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 really small number, which makes this a really, 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 really big number, okay? So that's why hydrochloric acid, nitric acid, whatever, none of the strong acids have Ka values because they're either really, really big or they're undefined, okay? There's the mathematical explanation as opposed to, yeah. I mean, I kind of understood that, but let's translate it a little bit.
My bad.
So what Evan said was right, though. He goes, fundamentally, what makes a strong acid is the fact that it completely ionizes. But because it completely ionizes, that led to Christmas's statement that this becomes zero. And these numbers here, if it had been a strong acid, like this would have been 0.2 molar, okay, because it would completely ionize. Okay, so on your rice chart, and yes, if you hand in that test when you get done on Monday, and if you haven't written lots of rice charts, you have done something horribly, horribly wrong, okay?
About to see a ray diagram on that test, Berg.
Huh?
With how confused I am, you're about to see a ray diagram on this test.
Oh, God. Here's the
the
light
ion.
going through the acid that splits it into a concave mirror.
Yeah, that's all right. That sounds reasonable.
Okay.
The next unit of physics.
So, how much of your acid is going to ionize? You don't know.
Here it is.
Now, if it had been a strong acid, how much of it would ionize? All of it.
All of it.
Velocity of the-
So this becomes X, this becomes X. Is this a buffered solution?
No,
How do you know?
didn't tell us.
I've given you no information about the COOH anion, okay? So you just have to assume this is a non-buffered solution since I haven't given you any information about that. So your Ka is going to equal basically X times X over 0.2. When you get the X, you have found what? Two things.
The
Concentration.
The concentration of your hydronium ions and the concentration of your anion, okay? But we don't care about the concentration of the anions because we don't have any probes to measure the concentration of COOH anions. Okay, so your Ka is 1.8 times 10 to the negative fourth. Going to equal X squared over 0.2. Now let's play the what if game. Okay, so somebody take a calculator, give me the value of X.
1.
0.006.
0.0.
Nah,
0.006,
Yes,
exactly?
yes.
molar. So there's my hydronium ion concentration. So from that, how can I get my pH?
Wow.
Negative log of that gets you what?
2.22.
2 places to the right of the decimal place, correct, Christmas? Exactly. Okay. Now, if you had another acid that had a Ka value of, let's say, I don't know, 4.7 times 10 to the negative 7th, okay, without doing any calculations, what's going to happen to the value of X? Will it be bigger or smaller than 0.006?
I don't know, what did you use, Kevin?
Different.
What was the question?
If the Ka had been 4.7 times 10 to the negative 7, would the value of X be bigger or smaller than 0.006? Smaller.
Yeah.
Actually,
Of course.
I thought it was over.
I guess I didn't,
Why would it be smaller?
Because everything else is
Smaller.
Because everything else is smaller, right? So your hydronium ion concentration is going to be smaller because it won't ionize as much. Okay? So what is that going to indicate about the strength of the bond between the anion and the hydronium ions if you were to compare a Ka of 1.8 times 10 to the negative 4th versus a Ka of 4.7 times 10 to the negative 7th? Which one would have the stronger conjugate base? 10 to the negative 4th or 10 to the negative 7th?
And the negative.
And like I said, it's more clumpy, right? It's clumpier. So, the smaller the value, the more clumpy it is. Now, this X would be a smaller number. So what would happen to the initial pH?
It'd be higher.
Bigger.
It would be higher because you're taking the negative log of a smaller number, you are going to get a bigger pH. Go with that.
Yes.
Got that. All the subtleties. All right. Oh.
We're just at the same time. It's crazy.
Now we got a buffer.
No, we have 4 buffers.
What? What was that? Why would you even add 4 buffers?
Why or
You good,
how?
Kev? You good? That wouldn't even make it that
You said
complicated.
it.
Yeah, let's just call it a day.
You should add the buffers together.
Let's just call it a day one day, Carnage.
I think so. Like, I think that
Okay.
was a
I
done.
made it up in my head.
Now, I'm going to add 100 milliliters of a 0.1 molar solution of sodium hydroxide.
Vacation.
Find the pH. What are you going to start with?
Equation.
The numbers. Yeah, what he said.
Equation.
Balanced equation.
Yes.
Yes.
Now,
Say the net ionic equation.
Yeah, net ionic equation.
that's varsity.
Oh, yeah.
Now,
Rookies out here.
because it's a weak acid, when you write the reaction, am I going to write it as hydronium ions or HCOOH? Which one?
HCOOH.
Why?
It's clumpy.
It's clumpy, okay? This is how it is existing. It isn't in the ionized form. Do I care about the sodium?
No.
No.
Don't care.
Don't
Now, out of this, what are you going to get?
water.
Water
What?
and
Anion.
an ion. Okay, it's gone buffered solution. Do you want to work moles or millimoles?
Millimoles.
Millimoles, okay. So I initially had 100 milliliters of a 0.2 molar solution. So if I take 100 times 0.2, I get
Something.
20.
20. You say that with absolutely no confidence.
It was a guess.
Then if I have 100
10.
milliliters of a 0.1 molar solution of sodium hydroxide,
10.
Yay.
I
I said that before. Yeah.
They're all
Question was over.
yay for mental math. So how much of my hydroxide is going to get used up?
All of it.
Oh,
All of it.
But hit you.
it's half.
Oh!
Half stabilized reaction.
It's half.
Half,
Neutralized.
half stabilized.
It's
Neutralized.
stabilized.
Bro, what? Neutralized.
Half equilibrium.
Half equilibrium.
How about it's half
Word,
neutralized?
my brain's like.
Stable now.
I
Your God.
So-
also write it out of the dictionary.
Here, if you want to drive me crazy on the test on Monday,
Yes.
you just randomly write down numbers and you put no millimoles, no moles, nothing.
Oh, you'll be lucky that you get numbered.
You'll be lucky to pass.
Yeah.
Cohen's gonna be writing hieroglyphics like if
Hey,
you
what?
Hey,
I
We're not
drove.
gonna get you like in blood stains.
I don't care what you work in. If you like zeros and you want to convert that into moles and waste a lot of time writing zeros, hey, cool, okay? You can do that. But what you cannot do in this, because it's fundamentally a stoichiometric calculation, you cannot leave it in molarity, because it's a certain number of millimoles or a certain number of moles. You can leave this calculation that we first did in molarity because nothing is getting used up. It's just searching for its own equilibrium. But as soon as you see any kind of titration, you work in moles, you work in millimoles. I don't care. Pick one. Personally, I'd work in millimoles because it's easier to do. Now, from here you have the Henderson-Hasselbalch, pH equals pKa plus the log of your anion concentration over the concentration of your acid.
But you're half
True?
neutralized.
Yes.
Now, if you were to look at a graph of the concentration of the acid versus the concentration of the anion as you add more and more sodium hydroxide, what would that graph look like?
Yeah.
It's that.
It's gonna start slow, then jump, and then.
This isn't pH.
Oh, my bad.
Well,
Wait, the
X.
Oh.
Oh.
That's the.
I'm a genius.
Charles, you gotta figure it out. He's better than all of us.
Because initially you're going to have a high concentration of your anion, of your acid, right?
You're next.
This is not pH.
All of us. Not.
This is not pH versus volume.
Yes. Good.
So the concentration of your acid as you add more and more base is going to do what?
Go down.
It's going to go down. What's the concentration of your anion going to do?
Go up.
It's going to go up. Eventually, what's going to happen to the concentration of the acid?
They're gonna cross.
Well, but beyond that, eventually it's going to go to zero because it's all going to get used up. At that point, it is neutralized.
Stabilized.
Okay? So the concentration of your anions are going to go up. At this point, where are you at? Half neutralized. Guess what? That's when your pH equals your
PK.
pKa.
Yay.
Yay.
I'm so tired of us. What we do?
Now, when you're half neutralized, what do you know about your anion concentration and the concentration of the acid?
They're the same.
They're the same. pH equals your
PK.
Now, somebody take the negative log of 1.8 times 10 to the negative fourth.
3.74.
That is
3 point what?
74.
I
Now,
do this. I need to
would you want to use formic acid to create a buffered solution of 6?
No.
No, why?
Because it's too far.
Your pH is, your pKa is well aware from where you want to end up, okay? Would you want to use it if you wanted to end up with a pH of around 4?
Yeah.
Yeah.
That's pretty good.
That would be cool. Now, mathematically, I want to end up with a buffered solution with a pH of around 4. Don't do any math
yes.
right now. Do you want the anion concentration to be bigger or the HA concentration to be bigger to end up with a pH of 4?
And I'm here tonight.
You want the anion concentration to be bigger or the acid concentration to be bigger?
Anion.
Why?
Because then it's positive, so you're
So,
adding.
because then you're taking the log of a number bigger than one, and then you're adding it, right?
You go in the right direction.
So you know, if you want to end up with an overall pH of 4, that anion concentration has to be bigger. Now, let's talk about this. Let's talk. If you're in this region right there, is your pH greater than, less than, or equal to your pKa? If you're in that region, that
Less
shaded
than.
region right there,
Less than.
why?
Because your acid concentration's higher, so it's below the pKa because it's subtracted.
Okay, beautiful. So if you're in this region, your acid concentration is going to be bigger than your,
Anion.
which means you're going to be taking the log of a number less than 1, which means you're going to, so your pH is going to be less. Once you're at that point, then what's going to happen?
Equal.
Then your pH equals your
Yeah.
pKa.
We got this, yes.
Once you get into this region, then your pH is going to be
Bigger.
Bigger.
Bigger
We
than
just did that one.
pKa.
That was the first one, that was the first one.
Sorry, it's the opposite.
it's going to be bigger. Why? Because then your anion concentration is bigger than
One choice
your
left.
acid concentration. Okay? Cool with that.
Yes.
Okay.
I got confused
Yes.
with the, like,
Now,
Whatever you say.
greater than, less than marks.
Pretty much.
I'm going to add, where were we at?
Which number do I want?
I just got trained at like 2nd grade, so I never made it up.
Which way?
My bad, when you leave.
No clue.
Now I'm going to add 200 milliliters of a 0.1 molar solution of sodium hydroxide.
I thought I knew all.
Oh no, they're gonna be.
So I'm going to have the acid, right?
No. I would never do something to that.
So I got 20 millimoles here, 20 millimoles here.
You have a test X fault.
It's really
Won't be spaced out. Correction of whatever.
So now is the pH just going to be 7?
No.
No.
It's neutralized?
No.
But you gotta do
Secondary reaction.
Secondary reaction.
Because formic's clumpy.
Secondary.
No bueno.
Formic
Now,
is clumpy.
There you go.
if this had been like nitric acid, okay? If this had been nitric acid and sodium hydroxide, then when it was fully neutralized, what would the pH be? Why?
Strong acid, strong base.
So that is not the reason why. There's a horrible explanation.
Conjugate base.
What about the conjugate
It's
base?
really, really weak.
So what?
It is no
Oh, there's no secondary reaction. So if it's a strong acid, strong base,
The vacuum,
you still have the exact same neutralization reaction. The anion is there, nitrate, chloride, whatever. But what is not going to happen? No secondary reaction, because by definition, strong acids have incredibly weak bases. So therefore, it would be there, but it'd be like, yo, whatever, don't care. Now, the anion, though, because it's the conjugate base off of a weak acid, what's going to happen?
Clump up.
Now it wants to get clumpy. Okay?
That's it.
So,
I'm gonna get
now, what's going to be the next reaction?
You have to divide by one.
No. We'll get to that point. I just want the reaction.
Your A minus plus your water yields your acid plus OH.
The acid and,
OH minus.
minus.
this is key, I'm going to make hydroxides.
Now, this is a molarity.
Stop one. I'm not doing anything.
And to think I briefly thought, you know, I kind of miss my kids.
Oh,
Briefly.
briefly, and then here.
Honestly, I'm I'm satisfied you made it there in the first place.
Yeah.
Now, am I gonna leave this as 20 millimoles when I do this calculation? Absolutely not. It has to be.
Molarity.
So I had 200 milliliters of my base, I had 100 milliliters of
Throw anything.
my acid, my total volume is 300 milliliters. So I'm gonna take 20 millimoles and divide that by 300 milliliters, so I get molarity. So this should be 0.667. Huh? It is.
Oh my god, you're so good at math. You're learning. Oh my god, she's learning.
What did you know more?
18 years.
Let's go. I learned how to use a calculator finally.
Do you like me?
I love it. It's great.
Minus X.
Guys, I'm so good at math.
Look at the
about right.
The next one is fucking cool.
Okay.
That's where.
Now, is that going to equal the Ka value?
No.
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 The KB.
Value.
It's going to equal the Kb value. Why?
Because it's a base.
It's acting as a base. The
Oh.
anion is taking
We're
in
so bad.
a proton,
Jeez.
We're so bad.
generating hydroxide. Now, your Ka times your Kb equals what?
It literally says nut. Abby's right. Never say that. Abby, you don't never say that.
How about the auto ionization constant of water? It says it right there.
Yeah. Look at the shirt.
Where at?
Things not to do with work camp. It's literally number one.
Wait, what? Ka.
Sorry, I have
KB
business.
water?
Yes.
Why don't we say that?
No, it doesn't.
It doesn't. You tell me you look like K and KB and your paper just like suddenly like starts leaking
But
water.
it equals the volume of water.
It equals the
You know what I
ionization
meant, though.
of
That's
water.
really.
Why do I have to say extra words?
Communication is it the
I know what you
receiving of it?
mean.
If you
What
really
is it?
think about
I
it.
just say what I mean.
He's gonna punch you.
Just know what I mean.
Now, so here's,
I definitely don't speak for the truth.
I promise you, if you hand in the test on Monday and if you have not done a problem like this, you have done something horribly wrong. Okay? I'm telling you right now, if you hand in this test and you haven't done this, when you go through the secondary reaction and you find the Kb and you find the X value, which is your hydroxide, your PO, you have done something horribly wrong. Okay?
Berg, if I make it that far, we're cheering anyway.
Okay, good for you.
Yeah, good for you.
So your Kb is going to equal x squared divided by 0.0667. Once you get x, what does that get you? Hydronium or hydroxide?
Hydroxide.
So when you get x, that gets you your hydroxide ion concentration. When you take the negative log of that, that gets you what? Your POH. And then you subtract that from 14 and you're going to get your, should your pH at the equivalence point be bigger or smaller than 7?
Bigger.
Bigger because you are generating
OH.
OH ions.
Yes.
Okay?
So good. We're so bad. Taste them.
I feel fine about this one. It's the quisp that scares
The
me.
quiz.
Yeah, the quisp is bad.
Quisp. You have kisp and quisp.
He's not wrong.
There's no way none of your
See how we
students have
find
said
the
that
acid
before.
base, but they can't take the test?
Never.
What?
Ow. That's.
I'm not that clever.
We got Clumpy and
I
Quip.
realize that, but never heard it.
We got
It's kisp and quisp. That it just makes sense.
we now have Clumpy, Quisp, and Quip.
Quisp and quisp.
You call
Sounds like you have
Quip
a
and Quip.
Why won't you call them my
Sounds like I have a
Wait,
wisp.
what, you mean a whip? What's your Quisp?
Can I have a whiff? Whiskey. Have a little whiff.
Why are you sound like Mike Tyson?
The cat, the cook.
I don't hate to see you coming.
Why am I psychic today? Hopefully I can get the answers on the
Isn't it
test.
like middle school freshman
Just
Do a
year
little bit of
about
this,
just
do a little bit of that.
How do Irish people talk?
Hopefully, like, I just start thinking.
No.
of-
Is that what Lucky Charms look like?
Hey,
I'm drawing it from
Hey,
memory.
we're doing
I
buffer
can actually
solution
just
now.
spell it.
Like, what if we
This
were
is a
doing
water.
oh, titration.
Yes.
Shucks.
Abby's cat's name.
Okay.
We're locked in.
Now what has changed?
It's buffered.
Buffer?
It's buffer.
What two things do you need to have a
Oh my
buffered solution?
Salt and weak acid.
It's a weak acid and the salt that contains the anion
Of the
of the acid, right? Okay.
So much sense.
So now is this a buffered solution?
Yeah,
Yes.
sure looks like it.
Looks like it.
Probably.
Whatever
If it's not, I'm in
whatever
trouble.
you tell me.
So is the ionization reaction still the same?
Yes.
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 Okay? You're gonna still make hydronium ions. Now, before you do any calculations at all, do you think the pH is going to be bigger or smaller than what we initially found? The initial pH we found to be 2.22. When I find this pH, is it gonna be bigger or smaller than 2.22?
Bigger.
Bigger, why?
Buffered solution.
Adding
Buffer.
an
You cannot just say, it's a buffered solution.
It's
Adding
buffered.
more
Because
anions.
you're adding, that's
I
why.
said it's
Anions,
better
so
than
that's
the-
oh, I think
1G.
you're adding more anions, and so the hydronium has to be smaller mass to have the same pH.
So therefore, you're taking the negative log of a smaller concentration of your, so the pH is going to go up.
Yes.
Okay? Now,
Good.
because there was something very important that 1G said. Mother Nature wants the same Ka value. So by making the anion concentration bigger, to get the same Ka value, your hydronium ion concentration has to be
Smaller.
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 And less
So,
the brain is.
I got 100 times, I got 20 millimoles of this, right?
Makes me feel.
My COOH is going to be 50 times 0.2, which is going to be 10. Now, is this a neutralization reaction? No. So that's going to be minus X. Okay? Now, so because of the fact that looking at this,
It kind of sounded like it.
you have unequal volumes of this. You have 100 and you have 50. Okay? So can we just go off of the number of millimoles? No. It has to be the concentration after they are mixed. Sean, after you mix them, what's the total volume?
150 milliliters.
Now, here's the bigger idea. You're gonna take this, divide that by 150, you're gonna take that, divide that by 150. Because you actually have to have, and this is gonna be true of QSP as well.
He's being so annoying.
No, I'm not. I'm being hilarious.
There's a fine line.
I know where the line is.
I don't think.
Yeah, and you running jump.
So,
You don't even know how.
here's the point. When you do the Henderson-Hasselbeck equation,
I jumped in my school.
To dump the ball.
okay?
Can't run and jump.
By the virtue of the fact that it's a buffered solution, is that gonna change your pKa value?
No.
No, it's not going to change the pKa value because that's fixed. Now, let's just look at this. So, you've got 10 millimoles and you got 120, then you got 20, and you're dividing both by 150. So your anion concentration is gonna be 10 over 150, your pH over here is gonna be 20 divided by 150. So, am I gonna be taking the log of a value bigger or smaller than 1?
Smaller.
Smaller than 1, okay? So, when you look at this and how you calculate this, when you look at your pH calculations, okay, and if it's a buffered solution, the biggest thing you have to realize is that this is not starting off at 0. Your hydronium ion concentration is starting off at 0. So you need to go plus X, and you need to go through all of that process. Okay. Let me say I give you this question. Let's talk about magnesium hydroxide ionizing into
Is this a crispy problem?
Please don't be quiz.
How about this?
It looks like it's a
Not
crispy
quiz,
problem.
no.
This looks like a crispy problem.
Kiss me?
That is not so bad. You promise?
Gotta give you
Okay.
a big kiss out.
so.
No, it's a crispy
You are
problem.
given a solution of magnesium, a powdered solution of magnesium hydroxide that dissolves in water. At equilibrium, you measure the pH. The pH is 8. Find the KSP.
Oh,
Okay, well, you have your hydroxide concentration because you have pH, and then you can just do the thing.
Yeah, the form, yeah, the magic thing where do
Okay,
the oracle will tell me the answer.
when you're talking about KSP,
Tell me the answer.
is the story,
Speaking.
is the story the precipitate, or is the story the solution? The story is the solution, the precipitate is not the story. In this situation, how are you going to calculate KSP? Your magnesium ion concentration times your hydroxide ion concentration
Squared.
squared.
How do you have to
Because
square?
there's a 2 in front of it. I promise you,
Our arms aren't the same length.
this is what you're going to do wrong. You're going to forget to square that,
Just go like this.
okay? And you all sit there and go,
Shorten it to the length of your thumb. Square.
Square it. Visual representation.
It helps them remember.
Oh, that's a square.
They're gonna do that in the test.
To me,
Monday
Monday's
is
better
going to be
than
such a long day.
How's that?
Actually, Monday night
Me
when
and Chuck have
we
better ones.
So,
Don't even. Still a rectangle.
don't forget to square this. Now,
You said just the length.
if I know the pH is 8, what can I find? Then my POH is going to be
Throw a big sign.
Wait, what?
6, right?
Yes.
So if my hydroxide ion concentration is going to be 1 times 10 to the negative 6th, right? Because that's what that means, right?
Yeah.
So is my magnesium ion concentration going to be twice that or half that?
Half.
Half. Why?
Because it doesn't.
Because I get 2 hydroxides for every 1 magnesium. So that means if you take 1 times 10 to the negative 6 and then divide that by 2,
Yes.
5 times 10 to the negative 7. Now, before you do any calculations at all, is your KSP going to be, Charles,
Shut up. Be quiet.
is your KSP going to be a big number or a small number?
Small.
Very small.
Just like Ka values, because the forward reaction is not favored. By definition, though, what makes these things insoluble is that at equilibrium you have very small concentration of these ions. That's what makes them insoluble. If they were soluble, guess what? The KSP values would be really, really big because the ions would dissociate.
Cool.
Okay? All right.
Big twist.
So, To get the actual KSP value, what are you gonna do? I'm gonna take my magnesium ion concentration, which is 5 times 10 to the negative 7, and then I'm gonna multiply that by my hydroxide ion concentration, which is 1.0 times 10 to the negative 6 squared. And what do you get?
5 times 10 to the negative 19.
5 times 10 to the negative 19. Okay?
Makes sense.
Makes sense. Makes sense.
I was getting.
I
Now,
don't know what I'm doing.
Uh-oh. Another
No, we're done.
precipitate.
Not, no, this is gonna be a quiz.
Strontium
Freaking quiz.
carbonate and silver chloride.
Quiz is my number one hobby. Like I go home every day and I write my diary. I hate quiz, I hate quiz, I hate quiz.
okay. You have a beaker that has 2 precipitates in it. One precipitate is strontium carbonate, the other one is silver chloride. Okay?
Oh, wait.
It's gonna be.
But that'll do the, no. Wait, yes,
Free will.
The H,
Yeah,
the H, the nitrate will go to the chloride to make more.
I see what you're doing.
No.
Yes.
You have
The H.
2 precipitates in this beaker. I'm going to add nitric acid to it. Which one will dissolve and which one will remain as a precipitate?
Strontium
Strontium
carbonate
dissolves.
Strontium dissolves.
Because
Why would the strontium carbonate dissolve?
Carbonate's
Strong
clumpy.
acid.
It's a carbonic acid. It's a strong conjugate
Okay,
base.
visualize this.
Oh, yeah, carbonic is weak, yeah.
Chloride is strong because it doesn't want to.
Yeah.
It doesn't want to.
What are the ions lurking in the
Shut
solution?
up.
Up here, what are the ions in that solution?
SR2 plus, CO3 2
have
minus,
strontium
Ag
2
plus,
plus.
Cl minus.
You have carbonate 2 minus,
Okay, try hard.
you have silver ions, and you have, again, do not focus on the precipitate, okay? Focus on the solution up above.
If you say so.
Are you gonna worry about the nitrate?
No.
No, not part of the story, okay? Don't even worry about it, it's not there, okay? Not there, not part of the story.
Always.
Along comes the hydronium ion. Is the hydronium ion gonna bond with either the strontium or the silver?
No.
No, why?
Similar charges.
They're both positively charged, they don't care, okay? Not going to happen. Is the hydronium ion going to bond with the chloride ion?
No.
Is this going to happen? H plus Cl minus forming HCl.
No.
Is that going to get clumpy?
Never.
Why?
not
It's not clumpy.
Oh, we should
Okay.
debate.
Conjugate base.
Not gonna bother it. Now, you have a carbonate ion.
That'll get clumpy.
Why?
Because it's a strong conjugate base.
Off of a.
Weak acid.
So when I ask you this question, and I'm going to,
I will
okay,
get it wrong.
if you hand in the test and if you have not explained how you can separate 2 precipitates based upon their conjugate bases, you have done something horribly wrong. Okay?
Looks like I'm gonna be doing something.
So, here's what's gonna happen. The carbonate ion, which has a charge of 2 minus, is gonna take in 2 hydroniums and we're gonna form carbonic acid. It's going to get clumpy. Why? It's a weak acid, so it has a strong.
Conjugate base.
So what's gonna happen over a period of time to your carbonate ion concentration?
Go down.
Okay? Because of the fact that it's bonding with the hydronium ions. So to make up for this, what's the only source of carbonate ions to maintain equilibrium?
PPT.
The precipitate. So the amount of precipitate is going to go
Down.
down, okay? But what's going to happen to the amount of silver chloride precipitate?
Stay the
It's going
same.
to stay the same. because you're not changing the concentration of the ions. Are the carbonated ions still in the solution? Yes, but they're not existing as,
Ions,
they're existing as
weak acid.
the weak acid. Okay? All right? So find the one that has the conjugate base off of a weak acid. That's the one that's going to dissolve because you're going to drop that concentration. And that's how you want to explain it. Okay? You need to say, oh, it's going to dissolve. And if that's all you say, bad things are going to happen. Okay? You want to articulate why it's going to happen. Okay? What's the only way that you can decrease the amount of precipitate?
Adding a strong acid with the same.
Or
Yeah.
fundamentally dropping the concentration.
Concentration decreases.
Therefore, the only bank that you can draw from is,
Precipitate.
okay? All right.
What?
That's fine, sorry.
This is a
Have you
titration
ever done
graph?
a QSP round?
Yeah, QFP's easy.
Okay.
This is what I was talking about earlier.
Oh, wait, no, I know this.
Based upon this graph, Sean, is this the titration of a strong acid or a weak acid?
Strong acid. Weak acid.
Why?
Get a bitty shot on this.
I don't know.
Oh.
was a belief.
Where's the pH at the equivalence point?
Over 7.
It's above 7, so therefore, there was a secondary reaction that created
OH.
OH.
Where he drew the line.
Yeah. But like, look,
That's why I specifically drew that where it was above 7. Now, let's say that that was 24 milliliters to reach the equivalence point.
Okay.
Wow.
How could you use that graph to find the pKa of the acid? Oh, go to half the,
Equivalent, and then whatever the pH is at that point.
which would be 12 milliliters, and then you'd come up here, and then you'd find your,
pH.
and let's say that was, I don't know, 4.50.
Close.
If that was 4.50 at half the equivalence point, if that was the case, then, because remember, pH equals your
pKa at
at half the equivalence point, so if you know what the pH is, you know what your
PKA.
pKa is. So how could you find the actual Ka value?